Hello everyone, welcome to Tip Top C Sharp tutorials. So in this video we are going to discuss about C Sharp generics, especially a topic about custom generic types. So let me show the agenda for today. Custom generic types and the constraints on type parameters for a custom generic type. And finally we will discuss about limitations of custom generic types. So first, let's take a look at the custom generic types. So what is the need of custom generic type? It's a template-based approach wherein we can create a custom type and later on the consumers or developers can supply type parameters to it. So the objective or the advantage of custom generic type is to reuse the same class for different needs. Let's say you have some utility class and you have to use it for multiple types. So in generic, at a time we can use it only for one type. So if you want to use it for multiple types, custom generic type is the way. Let's take a look at the code base so that you will get a hang of what it is. Well, this is the sample code for custom generic classes. So here is custom generic type. I have defined my custom generic with a type parameter t. And what it does is it will accept any of the type parameter, and we can try to do one thing. We can try to print the type of this custom generic right line, and we can say here is the type of generic, and we are going to append type of t. T is our parameter. Okay, close it. So we are going to call this method over here. I'm not initializing or assigning to a variable here. I'm just directly calling this print type method, and let's see what is the output. I'm going to show you the output for this one. So it's printing. Here is the type of generic system.string. So similarly, we can change the type here and see what happens. Int, int. Okay, I'm going to run it again. So here is the type of generic. It says system.int32. So this is the basic idea of having a custom generic. You can supply different type parameters and see what is the output type, and depending on the context, you can use respective types. Let's move on to the next section in this video, that is constraints. So I don't. So if you want to add a compile time check or a validation of the type parameters, we need to have certain mechanism to do that. So if you see here, uh, my custom generic of type T, it could be any type. So this T can be any type in .NET. But as you know, we cannot use any type anywhere. There could be scenarios where certain types are not suiting your requirements. When you define your design, all the types may not be suitable for that particular problem solution. So what we are going to do that for that .NET framework is supplying a lot of constraints. There are 5 possible constraints for generics. We are going to take a look at the code, but before that I will just list down it. Value types, reference types, default constructor, base class, and interface. These are the 5 possible constraints for generics. Let's take a look at the code. So if you see here, first one is my generic with value type t, where t is a struct. So this where keyword is used to define a constraint. We are telling the compiler that when we define a type, the t should be a value type, which is of type struct, as you may know. And how do you restrict it to reference type? It's very simple and straightforward. Again, we will use the word keyword where t is a class. So whatever type inheriting from class will be only applicable for this one. Otherwise, you are going to get a compile time error. So everything is validated in the compile time itself. So you don't need to worry about the type mismatch or different type anomalies at runtime. And there could be use cases where you need to have a default constructor for your type, let's say serialization in .NET. If you want to serialize a class, it should have a default constructor, a public constructor. So in such cases, we can make use of this new braces keyboard. So by supplying this constraint, if you are using the type, then definitely it will demand it should have a default constructor. Okay. And what if you want to adhere to a inheritance hierarchy? Let's say you have a base class and you want to derive all of your generic classes types from this generic base. So this is the syntax for it. We'll supply word t is my generic base. So my generic base is a dummy class I have created for illustration. And again, apart from inheritance hierarchy, if you want to have a interface based implementation, you can make use of where t is my interface, meaning that whatever type you're supplying at runtime or compile time, it should be one of the implementations of my interface. So this is the basic possibilities of constraints, but you can mix and match different constraints uh, with a permitted combination. We cannot have both struct and class because these are two different hierarchies. But you can have a struct with generic base or a class with generic base and my interface. So different combinations are there which you will apply when you define the design. That's about constraints. So what are the limitations of a custom generic type? It's very important to understand you cannot do everything in a custom generic type, right? So the first one is operator constraints. So what we mean by operator constraint is uh, we cannot apply certain operators on the custom generic type. To show you the example, let me get back to the code. So I'm trying to define one generic calculator here by supplying type value as t. I'm just creating an add method which will give me again the same type, and I'm supplying two parameters, two numbers in fact. So let me just comment this code out, then I will show you what is the meaning of default t. So if you mouse over here, you will see a warning: operator plus cannot be applied to operands of type t and t. So meaning that custom generic type does not support plus or minus or this kind of operations, especially arithmetic operations on this types. So that's a limitation, but there are different ways to work around it. Okay, so let me put the default value here. So whenever you work with generics, you will have to use this default keyword because you don't know what type this would be at compile time. So the one of the good idea that Microsoft Framework has provided is a default keyword. So you just need to type this default of t. This whatever be the type, it will take the default value of that particular type. If it is integer, it will be 0. If it is a reference type, it will be null. Okay. So to enable compilation, I am just putting it back to default of t. But keep in mind that default is a good keyword which comes handy whenever you deal with custom generic types. So how do you create a custom class that will have a lot of operands or operations? So we can have a base class with this custom generic. I'm putting an abstract method here, and again I'm creating a derived class by supplying the type parameter here, and we use the same method. We override the method and then apply the operator. So by this time, my int cal class would know that okay, this is no longer a generic type. Here we have a defined type of integer. Okay, so this is int and this is int. The return type is also int. So the constraint is removed or bypassed by using a different approach, having a base class and then deriving it. So we can derive from my generic calculator base for different classes. We can create my integer calculator, my floating point calculator, my double calculator, so on. So that is the beauty of this workaround approach. So I'm switching back to the PPT. So we have discussed about custom generic type, how to define it, how to apply certain constraints, which will be quite useful in design so that you can restrict or apply this constraint on the type. And finally, we saw one of the limitations of custom generic type and how to work around it. So that's it for today. Thank you for watching TipTap C# tutorials. Have a good day.